It's 3 o'clock, so let's get started again. So I posted the yesterday's video, and it's available in lectures, so you can take a look at that. Just as an announcement, as I've written on the board, class today will go from 3 to 4:40. So what we'll do is basically instead of an hour 40, which I know is an extremely long lecture, what we'll do is we'll have like a 40, maybe 50-minute first part, take a little break, and then continue until the end of 4:40. And since I know we had a lecture yesterday, and I know we're doing Tuesday, Wednesday, Thursday now, on Wednesday we'll just have a normal day from 3 to 4, not a long day. And then Thursday, a normal long day. Friday, no class. And then next week we'll resume the normal 3-day schedule. Okay? So any questions about that schedule? And one more thing. So obviously assignment 1 is out, and you should start working on that. But I have this other assignment, which is basically what we're gonna be doing as another assignment, which is scribing lectures. So how many of you have heard of scribing lectures or know what scribing is? So what it is basically writing up detailed notes about what we did in class. So I won't open these because they have your names on it, and it's obviously recorded. But what you'll do is you're assigned 2 lectures, one in the first half and one in the second half. And what you'll do is you'll look at what we did that day and just write a detailed report based off what we did that day, and then turn it in by a week later. Okay, so your day is written in there, and also the due date for each of the 2 lectures you are assigned to. Okay, and so since they're 5 points each, that'll be one whole assignment. Okay, and so that'll count as one of the 8 assignments. So it's not like another assignment I'm just throwing at you guys. It really is one of the 8 assignments. Okay, so any questions about that? Any questions about what we did yesterday, or anything about assignment 1? Anything related to that at all? Oh, and I should mention, today is the drop add deadline. So if you want to make any changes to your enrollment in the class, whether it be to add the class or to drop the class or change something else about it, today is the last day. So make sure to do it by today, because after today you can't change it. Okay? So any other questions before we continue from where we left off? Yeah.
Just take notes of the lectures.
Yeah. Well, obviously they're recorded, so you actually don't have to. So what you can do is you can read the lecture. You can watch the lecture once I post it, and then just write up a detailed report based off like we looked at this material, and we started writing these programs for the purpose of doing this. And just write a detailed report, basically.
Okay, so
yeah.
It's due about it's due on the date that's on here, but is that oh, never mind, I see.
Yeah, so
May 18th and then due certain. Okay.
Yeah, so each person's assigned a day to scribe a lecture, and then it's due 1 week later at midnight. Yeah.
You're looking for like an essay or just like a short paragraph?
Try to be. Obviously, it's worth 5 points, so it shouldn't be trivial, but it shouldn't be extremely long either. So something that just feels comfortable writing, like I'm writing so much about this one little program that we wrote in class. Do I need to write more? Just write what feels right. Okay. Yeah. So obviously, some lectures will be longer than others, but I'll try to keep it the same for each one. So, any other questions? Okay. And if we get through the Python material today, assignment 1 will stay the due date that it is, which is next Monday. If we end up spilling over to tomorrow, then it'll be due next Tuesday. So whenever we finish, it'll be due 6 days after that. Okay, so we were at here. Slide. Okay, so we've been talking about Python, obviously, and we were talking about the structure of Python programs. So what we were able to talk about were you can just run Python programs as is, right? You don't need some kind of class or main method or anything like that. You can just write lines of code and it'll just execute. You don't need some kind of long library call like system.out.println. You can just say print and it'll do that thing. There are no semicolons or curly braces in Python, so we have to distinguish between different scopes of the program, we have indentation. So do I need to have 4 spaces there, or what's the preferred method of indentation? So I can have a tab, or I can have any number of spaces. I can have 1 space or 1 tab. I can have 10 spaces. Any number is fine. But as long as it's the same indentation throughout the entire scope, then everything is fine. Actually, if Python sees that you have a tab and then the next one has spaces, it'll throw an error for there. But if it's the same for every single line in that particular scope, then you're all set. So we have else clauses, obviously, and we also have methods where we can call that particular function and then it'll execute the code in that function. We can define functions in functions that have their own if statements and body and all that. And we can obviously call functions. So we've been talking about these mutable sequences, which are basically these artifacts in Python where you can change the behavior and the value inherent within them, like a list, for example. So you can obviously, actually we'll get to this, but it's just, you know what a list is. You know what an array is. So you can obviously index into an array. You can retrieve a value in the array. You can set a value in the array. And they're just called lists in Python. So unlike Java and C++ and other programming languages that have explicit typing, Python has implicit typing where you can actually have any type of object you want in a list, right? So you can have a string, you can have an integer, you can have another list if you want to, all within the same list. Obviously, it's bad programming, but the type checking, as always, is done at runtime. Byte array is just an array of bytes. We won't actually be using that, but it's another mutable sequence. And then we've been talking about these things called sets, which are these unordered collections that have no duplicate elements, right? So, yeah, it's just an unordered collection with each element of the set is unique. And I'll get into what not hashable means, but it's basically the way that it determines if an element is in the set is that it computes the hash of the value that it receives, and then it figures out, is this hash in this set? Okay? So that's the way it actually figures out if something's in a set. So the way that sets are done in Python, just a short way, is with curly brackets. So it's not the same type of curly brackets to distinguish scope in, say, Java, but it's actually a comma-separated list within curly braces. Okay. So a sequence is just a finite ordered set that is indexed. So kind of like a list. It's just like a string and array in Java. So pretty much everything in Java, and actually pretty much any programming language, has a starting index, which always starts at 0, and then it goes up to n-1 if there are n things in the collection. So a string with n elements has index from 0 to n-1, as you may know. An array from 0 to n-1, but that's the same thing here in Python also. But you can actually make your own sequence if you want to. And pretty much every single object in Python that we will ever use is a sequence. So it turns out that sets are also sequences. So you can actually loop over a set and print the elements as you need, but it won't be in the same order that you construct it because it's an unordered collection. So let's actually look at that. So let's make an example. So let's make a set with elements 1, 2, 3, 4, 5, for example. So we're going to get into this, but the way to loop over any type of collections, like a string or a list, for example, is to do a for loop. So the way to do a for loop is not like a typical loop that you would see in Java. It's what's called a for each loop. So the way to do that is obviously the for keyword. So I think these lights hate us. I don't know. All right, so the way to do a for loop is for every single, and then you specify a variable in the thing that you want to loop over. So if we want to pick a variable name, say v, so this is going to be my variable that's going to be looping over the collection, which is s in this case. So the way to write that is for v in s. Oh, I should save that. So I'll save it as example 1 set. So the for v in s is basically for every single v that I'm going to call it, the variable that I'm going to loop over in this collection, which is this set. And then one thing we can do is we can print the particular value that we're looking at right now, which is v. So if we try to run this, so let's see if we have that. Yep, so if we have Python 3 example. So it happened to print it out in the particular order, but we know that sets are unordered collections, so there's no guarantee on the order. But since it's a sequence, what it does is it must print every single element only once. So there's a specified set of rules for how elements and sets are printed and indexed. It's not indexed, but like looped over. But since it's a sequence, we can print every element in it. Okay. So if we try to do, say, print s of 0, we know we can't do that because sets are not indexable. So if we try that, it'll give me set does not support indexing. Okay. So yeah, we'll actually talk about sets a lot more in detail as we go along. But for now, we know how to do a loop over it, and I'll get into loops in a second too. Alrighty. So we talked about sequences, so it could be applied to anything in Python. So there's this function called len, which we'll be using a lot. So what you do is you, like one of the other functions we did earlier, you can pass in a particular collection to len, and it'll just give the number of elements in it. There's no specified length variable that we access on the collection, but we just pass it to len, and it returns us the value. So if we try that for this example, so one thing we can do is print len of s. So what should I expect from this? 5, because there are 5 elements. And that's actually what we expect. Cool. But len can be applied to anything. It doesn't always work for sets. It also works for lists, works for any sequence. Because to be called a sequence, you must be able to call len, and you must be able to traverse over the collection. So if we make another, let's just make a string t, which has CSE294 is awesome, because it is. We can also do len on this. So if we do that and run, it'll print 18, which is the number of characters in the string, just as we expect. But, as I said, strings are also sequences, so we can loop over those too. So what if I did for a character in t? So what do you think character is going to be assigned? Well, it's going to be assigned each of the characters of the string in order. So if we print character, it'll actually print each of the characters on one line at a time. because the way print works in Python, it ends with a new line. So if we run this, as we see, it prints every single character on one line. And you think, isn't there an easy, wouldn't it be a nice way to have it so that it doesn't have a new line at the end? We'll actually cover that in a bit. But for now, we have covered sequences, which basically can be applied to most types in Python, such as strings, sets, lists, and pretty much anything. Okay? So any questions about any of the sequence stuff? Okay. Cool. So we covered sequences. So there are actually immutable sequences. So we were talking about mutable sequences, such as lists, where we can assign into a particular element of the list, or we can retrieve it if we want to and change it as necessary. So what do you think an example of an immutable sequence is? What's one in Java? That's a specifier that says we will never change the value. But like, what's an example of a class in Java that you cannot say change a particular element of? It's one that you use all the time. String, right? You can't say assign the 5th character of a string to be another character, right? So that's an example of an immutable sequence. And it turns out that's an example in Python. You can't change a particular character in a string. So those are immutable, just like in Java. So there are actually these things called tuples, and we'll get into more details what they are. But they're basically just an analog of list, but they're just immutable. So you can index into them, but you can't change any of the values within them. And you can't add any elements to a tuple, so it's a fixed length. Every single element is exactly, every single element cannot be changed. Okay? So those are examples of immutable sequences. Another one, just for completeness, is bytes. So it's just an array of bytes. That's an immutable sequence. We won't actually be using that. Okay, so comments. You probably have seen it already. Python is case sensitive, just like most other programming languages. Like variables are case sensitive, functions are case sensitive, all that stuff. No semicolons or braces. So that's one of the joys of Python, but obviously indentation matters. So comments start with a pound sign. So instead of 2 backslashes, it's just a pound sign. Okay? And then a multi-line is with 3 double quotes. So that's the way to have a multi-line comment. But actually, another thing you can do is this what I consider to be a comment is also a string too, because as we talked about yesterday, the single quote and double quote in Python are exactly the same. They don't mean anything different, right? So if we do an example, so example 2 comments. So we can have a multi-line string. So let's just say our string T is CSE294 is awesome. Next line is what's your favorite string?
What's your favorite string?
Yes. What's your favorite string? Actually, note something cool. Since I mentioned that single quote and double quote are the same, note that on what's there is a single quote, but it didn't end the string. Why is that? Because the string, what it starts with, must end what it started with. So if we have, so imagine that we had a single line string, so we would have a single quote. Although I can use double quotes, but I prefer to use single quotes. So let's say we have 294 is awesome. I actually have another name. But what if I wanted to include a double quote string? Do you think I need to escape it?
No.
No, because it must start with a single quote and end with a single quote, but I can have a double quote inside. So I can have a double quoted string in there. So let's just print both of these and see what happens. Print S. So let's try that. So Python 3 example 2 comments. So as we note, for this multi-line string, we have a new line character after CSE294 is awesome. And it actually printed that as well. So it includes the new line character there. And here for S, it actually included the double quotes in there because it counts it as a character. But what if I wanted to do that instead of double quoted string, I wanted a single quote? So what would I have to do there? Yeah, well, one thing you might try is doing it with a single quote, but as you know, it basically now is interpreting this first occurrence of that single quote as the end of the start string, so obviously we need to escape, and escaping works the same way as in Java, so which is a backslash. So obviously I need to do it here too. So if we run again, we now have a single quoted string. Okay, so as I said, single and double quotes actually don't make a difference. But one thing we can do is we can have a free floating string that actually isn't assigned to anything. So that's what the meaning of what I call the triple quote comment part is. So instead of assigning it to a variable, we just leave it as a string by itself. We don't assign it to anything. So obviously I can't print T now. And if we run that, it doesn't print that first string because it wasn't assigned anything. So in principle, it is a comment, but it's actually a string that just isn't assigned anywhere. But obviously, we have comments. So comments, as I said, start with a pound symbol. So if we have a pound symbol here, we can write a comment here. And if we run, it doesn't do anything because it's obviously a comment. Any questions on that? Okay. So we just covered comments. So as I've been talking about, sometimes I've mentioned like an integer as an object or a list as an object. Everything is an object in Python. So basically you can feed them to certain functions and they have certain methods applied to them. And obviously some are mutable, some are not, like lists are mutable, tuples are not, and strings are also not. Automatically garbage collected. So once you're out of the scope of a particular, once you're out of a particular scope, then all the variables within it that aren't going to be used again will be garbage collected, just like in Java. Okay, so that's fine and dandy and all, but what if I wanted to include someone else's code? What would you do in Java? What if you wanted to include java.util or something? You would do an import, right? Because obviously the Python library is very large, so it doesn't import everything all at once. So you'll obviously have to import. So basically, a file that contains a bunch of methods in it or a bunch of classes in it is called a module. And so what you do are importing modules. So it's just what we call a script is just a Python source file that's just executed by the interpreter. A module is just a file with a bunch of functions in it. Okay. So if we had a factorial Python file, so we would have one method factorial which takes an integer n, and it will return the factorial of the number. So what's an easy way to find the factorial of a number? Yeah, so n factorial is just n times n minus 1 factorial, right? So what we can do is we can just return n times this function fact of n minus 1, right? And then once we get to 1, what do we do? Well, we return 1, right? So, or if n is less than 2. We associate 0 factorial as 1 also. So we return 1 if we're below 2. Otherwise, we return the value times the recursion on n minus 1, which is basically exactly what the definition of factorial is, right? N times factorial of n minus 1. It actually almost reads like English, which is one of the awesome things of Python. But what if this wasn't included in my file? I would have to import it, right, if I wanted to use it. So one thing we would do is, so these 3 angle brackets represent the Python interpreter. And so I'll go through an example of this. But basically, we can import fact, which is saved in fact.py. So we're importing the Python file, which is the module which contains that function. So when we import a particular module, when we want to use a method within it, we call the module name dot the function name with the arguments that we need. So if we want to print fact dot factor, so the first fact is the module name, and the second fact is the function name. And obviously 4 is corresponding to n in the argument. Okay, so obviously 4 factorial is 24. 4 times 3 times 2 times 1 is 24. Cool. So let's do this as an example. So let's do a new one. So now, oops, no, I don't want to do that. So save this as fact.py just as we did in the example. So what I'm going to do is I'm going to write this method. So fact.py as a comment. Def factorial of n. If n is less than 2, return 1. Otherwise, return n times factorial of n minus 1. Okay. So now, since I'll just go back to the slide. As I said, these angle brackets represent the interpreter. So now I just want to show you that this works in the interpreter also, but you can do this as in the source file also. So how do I invoke the interpreter again? Python 3, yeah. So Python 3. So that's where the 3 angle brackets come from. So you may think, well, this is the interpreter. It may be in a different directory. But the really cool thing about the interpreter is that it actually is working in the directory that you're currently in, where you invoke the interpreter. So and to get out of it, you do Control-D or exit or something like that. So if I want to look at where I currently am in my directory hierarchy, I'm in this day 2 directory. And so I see fact.py. So if I just run Python 3 to get back to the interpreter, if I import fact, it'll import the entire module. And so what actually happened is this PyCache directory was made as just basically like a cache for being able to call functions a lot more quickly. Okay, cool. So if I wanted to assign the factorial of, say, 100, I can say fact.fact of 100, and then print. And then actually a really cool thing of the interpreter is that you don't have to call print in order to print the number. You can just type the variable that you want and enter, and it'll print the value of that variable, in this case s. So if I print it, it'll actually print the result. Can I do that exact computation in Java easily? No, it's because there's a limit on how large integers can be. But what happened here? It actually turns out in Python, there's no limit on the size of your integers. So you can make integers as large as you want. So I can actually do like 10 to the, actually I haven't done that yet, but I can do fact of 1,000. Maybe not that far. I think actually the depth of recursion is 1,000. So if I do 999, it should work, or maybe not. Somewhere between 900 and 999. So let's say 900, then I print S, very, very large number.
Is it accurate?
Yeah, it's exact computation. Yep. That's one of the really cool things of Python is that there's no limit to the size of the integers other than the memory of your computer. So more memory, larger integers. So you can do larger and larger factorial computations, which is something I really like. Okay, any questions about that? About being able to import things from other modules? It turns out that there already is a built-in function for factorial. So it's called the math module, which we'll be using a lot. So if we import math, math has a built-in function called factorial, like spelled out factorial. So if we do math.factorial of 100, it prints the same thing we did before. Okay, and it's built almost exactly the same thing as what we did there. But the difference is math is a built-in function. So we can call that from any Python file. Okay? Cool. And there are a bunch of other methods in math that we'll be looking at too. Cool. So we covered modules. We had this factorial function. And we were able to import that particular module, call a function on it, pass in an argument, get the result from it, just as we wanted to. Okay, but here's another thing. What if I had, say, a useless function that just returns the argument that was passed in? So, and my application that I'm building only wants to use factorial. So I want to be able to import factorial, but I don't want to import everything else because the module might be very, very large. So one of the awesome things of Python is you can actually import one thing from a module and not everything else. So the way to do that is, I should exit and then re-enter. So the way to do that, instead of saying import fact, which is the file that we've been doing, you instead of doing that, you do from fact import fact. So that obviously that first fact comes from the module. So from this particular module, import the particular function you want. And maybe we have some other function, square of n. So what it does is returns the square of a number. So return n times n. So maybe I want to import not only the factorial function, but I also want to import the square function. So, and I wouldn't want to type from fact import square. One thing we can do is import fact, comma, square. So we can actually, by doing a comma separated list, we can import multiple functions and not everything else in the module. So obviously we can do fact.fact of 100, but oh, okay, yeah. So, but when you do this, since you didn't actually import the module as a whole, you can't actually call the module, but you can call the function itself. So the function that we imported was called fact, so I can just call fact of 100. So don't be confused here. The fact that I'm going to be calling here is the function name. It's not the module name. So if I call that, it'll do it. And if I call square of 100, it prints 100 squared. Okay? So we have two ways to import, or the two ways to import something. One way is to import the entire module, which is just import the particular module name. The other way is to import a particular function that we want, which is from the module name, import the list of functions that we want. And then at that point, we just call the function name directly instead of calling module.function name. Okay? Everyone clear on that? Cool. Alrighty. So we did all this. So you may be thinking, well, we have these integers, we have this we have this list thing, we have these tuples you're talking about. What about something that's like a null in Java? Well, that's actually what is called none. So none is just basically no in Java. It does pretty much exactly the same thing. It signifies the absence of a value. It means literally nothing. So so we'll talk about numbers now. So as I said before, integers have unlimited range. As long as you have the memory to store it, you have unlimited range. The reason that we got an exception on when I did a very large factorial is not because the integer was too large for my machine, but rather that the depth of recursion got too large, where Python said, I think you may be in an infinite recursion, so I'm just going to stop you. So you can actually store incredibly large numbers as long as you have memory to store it. Okay? There's actually no limit for integers here. So we have a bool type. So like in Java, well, actually very close to Java, we have true and false, but the difference here is that it's capital T true and capital F false. But they mean exactly the same thing as in Java. So it explains the truthity of a particular statement or a falsity of a statement. Yeah?
Right. With the recursion limit, is there any way to make it where it can go deeper?
Yes. There's a I think there's a Stack Overflow post where you can actually set the depth of recursion explicitly, but by default, I believe it's 1,000, but I'm not entirely sure about that. Okay? Yeah, any other questions? What time are we? Okay. We have floating point numbers, so it's not just all integers, right? We have floating point numbers, which are just real numbers, just as always. Just like in Java, like for doubles and floats in there. We have this complex type, although we won't actually be using this unless you use it for your project, but it's basically modeling complex numbers if you know what those are. Okay? All right, cool. So now we're going to get to probably one of the most important objects in Python, which are called dictionaries. So how many of you have used what is called a map in Java? Or like a hash map or something like that? So what is a map in general?
You map a key to a string.
Right.
A key to a value.
Right. You map a key to a value. So that's exactly what a dictionary is in Python. So what you do is you map a set of keys to a set of values. So like in this in this dictionary, I'm mapping the string Ryan to the string Dougherty. So Dougherty is the value of the key Ryan, and the another key, which is Sam, and the value for Sam is Johnson. All right, cool. So what are some limits on dictionaries or maps if you remember? So it turns out you can't have multiple keys with the exact same I should say value, but it means something else here. But you can't have two keys which are exactly the same. Okay, so here I can't have two keys that are both Ryan or both Sam. Because what would that mean? Because if I wanted to determine if the value associated with the key Ryan, then I have an ambiguity, right? I can choose this value or this value. So the keys must be unique, but the values don't have to be. So I could have, say, Johnson for the value associated with the key Ryan. So the values do not have to be unique, but the keys have to be unique, because the way to determine the value is through the key. Cool. And another thing, just a minor point, keys must not be none. So it must be some not null value, basically. But that's just a minor point. Okay, cool. So any question on dictionaries? We're going to get into them later, but it's just a brief introduction to dictionaries. Okay, cool. So we have these things called callable types. So it's basically anything where you can apply the function call operator, which is just open paren, close paren. So obviously a function is a callable type, but you can actually do this on an object that you make, or there are actually some objects in Python where you can actually call an instance itself. So it's not a function, you're calling, it's like a special method called call in Python. We actually won't be using this, but it's just a function that's built in that you can call a particular instance. So it's basically you can model an object that you make as a function itself, even though it's not a function, because it's an object. Any questions on that? We actually won't be using that, but it's just worth to point out. Okay. So we talked about imports. So what if we want just one definition? We can just do from the module name, import the particular method, then just call the method directly. And we can have multiple definitions, as I said, but you separate with commas. So that's just what I did before. All right, so now to the fun part, which is input-output. So obviously the way through a program to determine a program's behavior is usually done through a particular input, whether it be from the user or from a file. So those are the two main ways to provide input to a program. So a file object in Python is basically called an open file. So it's not just like something .txt stored on your computer, but it could be what's called a stream, which is basically you write to the stream or read out from the stream. So an example of a stream that you've all been doing in Java is called system.in, right? So you construct a scanner object. I assume you've all been using scanner. So you pass in that system.in to the constructor of the scanner. Why do you do that? So it turns out system.in is what's called an input stream in Java. So what scanner does is it parses tokens based off of what it sees as a delimiter. So what system.in is, it parses a delimiter as a new line, which is basically you type in a particular input, push enter, and then scanner sees that as a token, and it returns that value when you say scan.nextInd or scan.next or something like that. So an open file here is basically the analog of system.in, but we also can write to a stream. So another one that you've seen in Java many times is system.out. So system.out is an output stream. And when you say .print, you're basically taking the result, the argument of print, and putting it into the string. Okay? And so that's basically what's called a file object in Python. So there are three types of objects in file objects in Python. sys.standardin. So sys is the module, standardin is the object. Sys.stdout and sys.stoderror. So what do you think stoderror is? stdin, so what is that? The lights just came on. Okay. What do you think stood in means? Standard in, standard out. So what do you think stood error is? Standard error. Is there something like that in Java?
Exception.
Oh, an exception is not the same thing. How many of you use like Eclipse or something? And when you got an exception, it was like all red text. That's standard, the standard error output. So you would wonder like, how do I write that to the console, right? Because all I know is system.out, right? Because when you write to that, that's just the black text. But how do I make it red? So there's a output stream analogous to system.out called system.err.println. So it has the same methods as out does, but it produces that error output. So that's how Eclipse is able to print that exception message to you. Okay, but the three ones in Python are standard in, standard out, standard error from the sys module. Okay, cool. So there's one gigantic method, which is called input, and it just reads from standard in, just like scanner does when you say like next in or something like that. Input takes in from the user up to the point where you push enter. So it's pretty much exactly the same. So let's do that. Let's do that as an example. So example 3 input.py. So we'll do this example, then we'll take a break. So one thing we can do is let's take in an integer from the user and print it square, right? So if we enter 100, we would print 100 times 100, okay? So the way to do that is s, so we assign to a variable s, and then just call input. That's it. Isn't that easy? But when you do input in Java, normally, like for any particular input, what's the return type? What's given to you? Like when I say scan.next, what is the return type of that?
String.
A string, right? So what do you think the return type of input is? It's a string, right? But obviously I can't do multiplication on, actually you can, but you can't do, we want to do the actual number times the actual number. So how do I change the string to an integer? Oh, int of the thing, yeah. So we can actually do this in two ways. So I can actually say the int is int of s. But another way you can do that is you can actually just call int of input directly. So just int of input. And so s is the integer we want now. So I want to print it square. So how do I do that again?
You mean do the entire import?
Well, I could do the entire import, which actually, since we want reusable components, that would be a nice idea. But what if I wanted to do it directly?
Print s times s.
Right, so one thing we can try is s times s, but this, I believe, won't actually work. So if we do Python 3, example 3, so obviously we need to take input, so that's why nothing was printed, so 100. Oh, it actually does work. Okay, yeah, so it depends what you're actually doing. So what if I wanted to do concatenation, like the result is s times s, because we do have that concatenation operator. So what would happen now if I tried to run with 100?
You'd get an error.
Why would I get an error?
Because it's trying to concatenate a string to another string, but it's an integer.
It's an integer, yeah. So we can't convert into str explicitly, so how did we avoid that?
Percent D.
Oh, what's that?
Percent D.
I actually don't know if we have formatting here, but what's a really easy way?
Convert half string.
Convert it to a string like we did with integer here. We just call str of the thing. And now since we concatenate strings, we can actually do this. So if we run, then we have the result. I'll have to look at that in a second. Okay? So that's how we actually get input in Python. But what if we wanted to display a prompt to the user, like enter a number, like we commonly do with like system.out.println, but how do I do that here? One thing we can do is we can do a print before. Another way is we can actually present the string in the argument of input directly. So we can say enter a number directly there. And so if we run again, it'll present the string to us, waiting for the input. So if we enter our number, we print the result as necessary. Okay? Any questions before we take a break? Okay, cool. Okay, we're back. So any questions on our example with input? All right, so just as a recap, the input function can take an optional argument, which is a string, which is the prompt that'll be presented. And it'll basically wait until the user presses enter, and whatever's been entered will be returned to the callee of input. So when we entered a number, it was passed to the int function, which converted it to an int, and we called print and passed in. We wanted to compute the square of the number, so we called s times s, but we couldn't concatenate the string. Concatenate that with the result is, so we just passed it to stir in order to get concatenation working. Okay. Cool. So we covered input. So it just reads from this file object stood in, and print just passes the argument of print to stood out. So it's basically the analog of print, but for output. The analog of input, but for output. So it automatically prints a new line, as we've seen when we did the CSE294 is awesome, and we did the for loop on that string, and we called print on each of the characters in the string, and it printed one on each line. So we can actually avoid that with what are called name arguments, which, in my opinion, is probably the best feature of Python, the most headache relieving thing in Python. But we'll discuss that in a bit. But for now, so what's another way in Java to get input? We have that scanner way, but what's another way?
You do it through the arguments from the main function.
Yes. So what is the signature of the main function in Java?
String
The string array args, right? How do you put something in args?
in the command line.
Right.
Next inputs or the
Yeah, so you actually pass it when you call Java. So the lights went off again? All right.
Their motion, I think, but I don't know where the motion is.
Yeah. So let's make a really simple class, hello world, for in Java. So I should save it, hello world.java, public static string args. So one thing we can do is just print all of the elements in args. So how many of you know the enhanced for loop in Java? So what does the enhanced for loop do?
these are just through every object in the whatever list or array that you do.
Right. So it's just basically an iterator over an array or some type of collection, if you have a collection. So every element's going to be a string, so let's just call it S. And basically, it's the analog of the for loop in Python. So there's only minor syntactic changes. Like, we don't have a type in Python, the variable's the same, and the colon in Java means the in keyword in Python. So otherwise, it's exactly the same. So for every string, so we can do system.out.println s. So we can try this. So Java, as we know from yesterday, in order to compile a Java file, we call javac, and then to run the file, we call Java on the file name without any extension on it. So hello world, compile, Java hello world. So it actually didn't print anything. Why?
You didn't pass it in here.
I didn't pass any arguments. So if I pass 100, it prints that. How do I add another argument? Space. So it's a space-separated list after the first after the program name. Then it's a space-separated list. So if I pass 200 here, it'll print both. Okay. It actually works exactly the same thing as in Python. Oops. New one. So the way to do that in Python is via the sys module. So I talked to you about standard in, standard out, standard error of the sys module. So in order to use those, obviously we need to import sys because it has the module name. But we also have this thing called argv. So what argv is, how many of you coded in C or C++? So the argv is the same thing here. So the naming actually comes from C and C++, I believe. So argv is just basically the same thing as in Java, where you pass in the arguments, and it's just basically all stored in this argv list. So we import the sys module. So the first argument is sysargv1. So sys.argv is actually a list. It actually isn't first argument since it's indexed at 0, but I just call it first arg. And then mystery is I call the argv of index 0. So, and then we can print, obviously. So let's actually do this as just to see what happens. So let's do import sys, and let's just call this example for argv.py. So first arg is sys.argv of 1. Mystery is sys.argv of 0. And print mystery first arg. So what would happen if I tried to run this as Python 3 just as that with no arguments? Yeah.
Print out example for our
Well, how many arguments did I present here?
0.
Actually, that's almost true, but
1, but it's
yeah.
the script name.
Yeah, we'll get to that. So what would happen for this first arg? It'll actually have an index error because the length of the list sys.argv is 1, so I can't index at 1 because it only has something at index 0. So it'll give me a list index out of range. But if I provide an input, so what should I have as the output here? So I obviously avoid the problem of having a list index out of range, but what will actually be printed? So there's obviously something going to be in mystery, something's going to be in first arg. So what'll be printed? You actually hinted at it.
Yeah, the name of the script.
The name of the script. So it differs from Java in that the first argument is the script name. So in this case, the script name is example4 argv. So if we run, it actually prints the name of the program itself. So we can actually get the name of the program in argv, which I think is pretty interesting. But obviously, the rest of the arguments are based off of the space-separated list that you provide to the program, just the same way as in Java. Okay? And so that's another way we know how to get input. So we know 2 ways now. We know how to get it from the user, where they type in an input and push enter. And then another way is to get it directly from the calling of the file. Okay? Yeah.
So if you put 2 inputs in, will it still print out the name?
Oh, yeah, good question. So if I try to put 2 arguments here, so what would actually be printed? Exactly the same thing, right? So what are the contents of argv now? How many elements does argv have? It has 3 now, right? So what are the 3 arguments? The 3 values. The script name as what is the type of it? String. And then the next thing is? 100 as a string. Yeah, it's a string now. And so sys.argv is a list of strings, and the third one is obviously 200. So, but we only print the 0th index and the 1 index. So if we run this, it'll print the same thing. But one thing we can do is we can actually, as we did with the strings and with lists, we can actually loop over sys.argv. So with that enhanced for loop, the for each loop. So if we do for, then the name of the variable that we're going to assign to each of the elements as we traverse it. So if we call it v in, so the in keyword for every single v in this particular collection, which happens to be a list, and sys.argv, print v. So if we run this with example for argv.py 100, 200, it'll print all 3. Okay, so we can loop over this also. So any questions about how this works? Okay. So we know how to get argument input now. So all we need to do is import the sys module and then just call .argv with a specific index into it. Okay, cool. So as we know, expressions are just statements that evaluate to a particular value, right? 2 plus 3 is an expression which evaluates to 5. 5 times 3 is an expression which evaluates to 15, etc. So obviously we can have mathematical statements like 2 times 3 minus 5, and obviously that the value of that is 11. If either operand is the complex type, it'll convert to complex. So obviously we're not going to be using complex a lot, but it's just worth noting that some types will implicitly convert to other types. Whereas like for ints and stir, we saw that the integer did not implicitly convert to a stir, but it does here. So a complex, if either operand is a complex number, whatever the other one was, the result of it is still going to be a complex number. Okay? If either operand is a float, it converts to a float. Otherwise, both arguments must be ints to an expression. And the evaluation is the same. So everyone knows PEMDAS, right? The order, so parentheses, exponentiation, multiplication, division, addition, and subtraction. So let's go over the various operators. So there are a ton of operators in Python. So we've seen a few, like the plus, times, divide, and multiply. So the lights went on again. So those are 4 operators in Python, but we actually saw another one, which was the in keyword. So that is actually an operator. And there are actually quite a few others. So it's what's called the Operator Precedence Table. So the first one we're going to cover has the highest precedence, and then we're just going to keep progressively getting to lower precedence. So the first one is, what are the angle brackets representing that we've seen so far? Something to do with lists, or rather just like indexing into a particular object, right? You can actually override this to mean something else if you make a particular object, but for lists and the like, it's just indexing into it. So we know the open and close paren means some kind of function call, right? And the dot is just basically look up a particular value on some type of object. So we've seen that dot actually used when we did sys.argv. So we didn't actually call a function, we looked up a particular property of the sys module, right? And actually one really cool thing of Python is you can disguise function calls as a property lookup. So in the backend, this might actually be a function, but you can disguise it as a property. So we won't actually cover that, but that's a really cool feature. So it's just making the interface a lot easier for developers without having to look at this complex function. You just look up the property itself. But it may also call a function. Cool. But what is that second one with the 2 arguments in between the square brackets? So we know the square brackets means something to do with indexing into something, but what do you think those 2 parameters correspond to?
Split.
It's kind of like a range. So what this usually means is we want to look up from index n up to, but excluding index m. So that's what's called a slice, which is an awesome name. So let's work on an example of this. So save this as example 5 slice.py. So let's just say we have this string CSE294 is awesome. And so what if I wanted to print from the 2nd index to the 10th index? So one thing you can, the way to do that in Python is to do a slice. So, but another thing you can do is just print s of 2, print s of 3, and so on, but that's kind of repetitive, right? We want an easier way. So if I want to print from the second index to the 10th index, so what would n and m be here? Sorry, n would be 2, but m would be 11. Good. You guys are so smart. It's so awesome. So we would have 2:11. So if we ran this, Python 3 example 5, so it'll print from the second index, which is E. So 2 is 3, 4, 5, 6, 7, 8, 9, 10. All right, so it should end on A, and which it did. Awesome. Cool. But what if I wanted to print from the second index all the way to the end of the string? But I don't want to look up the length of the string, which I can with len, but I don't want to have to do that. So what would I change about this? Remove the 11. Good. So both of these operands, if you like, are optional. So what the second one does is start from the second index, go all the way to the end of the string, and print that entire thing. Okay? Are strings mutable or immutable? Immutable, right? So what are these doing then? The slicing operator. It's making a new string. It's not looking into the old string. It's making an entirely new copy of the string because it's immutable. Good. So if we look at this, it prints to the rest of the string. Similarly, if we want to say everything up to, say, index 5, what would I have to do here? Almost, :6, because of the exclusive on the upper end. That's actually what happens in a lot of standard libraries, is that if you have a lower and an upper range, what usually happens is that the lower is inclusive, but the upper is exclusive. That's what usually happens. There are actually some cases where it has to be inclusive, but most of the time it's exclusive on the upper end. So if we print this, it prints the up to index 5. So 0, 1, 2, 3, 5. Yeah. So it prints the CSE294. So what do you think happens if I omitted both of them? I have S of just the colon itself. What do you think that does? It gives you everything. Since there's no lower and upper limit, it prints you everything. So what is this actually doing? What is it giving me? A copy of the original string. So if we run that, it prints the entire string. But what if I wanted the last character and I didn't want to look up the len function? If I did want to look up the len function, it would be S of what? If I just wanted the very last character and that's it. We'll get to that. But it's going to be len of S minus 1, right? Because it goes up to 0, from 0 because it's indexed at 0 to n minus 1. But what if I didn't want to do that? I didn't want to look up that len function. Anyone know how to do that? So it turns out there are negative indexes in Python. Isn't that cool? So a negative index starts from the right-hand end and moves its way forward. So if I wanted the last element, what should I put as my argument? -1, yes. So if we actually do this, it prints the last character.
So if you did -1 colon, would it give you the reverse of the string?
I can actually do an example of that, but it actually won't work that way because it's from the first to the second, so it's always forward iterating. But I'll get to that in a second. So what if I wanted the last 3 characters?
-4.
Well, obviously I can do -3 plus S of -2 plus S of -1, right? I could do that. But what's a way to do a slice on that? -3, since it's inclusive on that end, colon to the rest. So if we do that, it'll print those 3. But I'm not sure if I covered this in the slides, but there's actually a way to, there are actually 3 arguments you can provide to a slice. So instead of just an upper and lower limit, you can provide what is called a step. So what you can do is instead of going every single character, you can go every other character or every third character, or what else? Characters backwards. So let's just print the entire string. So the first colon means the first argument I left out, obviously. The second one I left out. So as we just discussed, that's a copy of the original string. Yeah.
Is there a particular reason you are just doing print s in that case, rather than adding the colon?
Yeah.
You know, whatever. I mean, save your keystrokes.
Yeah. So it's not entirely used a lot with strings, but it's used a lot with lists because I don't want to modify the original list. But obviously, since strings are immutable, we can't modify it, right? So it's used a lot with lists, not a lot with strings. But I'm just doing this as an example because if you really think about it, strings are just arrays of single character strings. It's really the same thing from a interface point of view. All right, so if we just left this as is, it returns us a copy of the original string. But as I said, we can have a 3-argument slice, which means we would have to have a second colon. So obviously there are 3 places in here now. So first index is the first parameter is the starting index, which is emitted here. Second index means where we stop, and the third one is a step. So what if I wanted to print every second character from the start? I would put the step as 2, right? So if I put that, it'll print that weird string. So it prints every other character in the string. But getting back to what was asked earlier, what if I wanted to print the reverse of the string? So I want a copy of the original string, right? I want to go from the beginning to the end, but what way do I want to go? Backwards. So what should I put as my step? -1. Yeah, good. So if I do that, it prints the string backwards. So that's an extremely simple way to do it. There's actually an easier way there is a function called reversed, which returns it doesn't return the reverse string, but it returns an iterator to the reverse string. So there are actually 2 ways to do reversing. But obviously I can modify this to say the string backwards, but every third character along the way. So I can do that also. So I would do every third character starting from the end and doing every third character until I got to the beginning. Okay? So any questions about slicing? Obviously, I'll provide all this source code, so you can play with this as much as you want. There. Cool. Let's go back. So we have subscript, which is the brackets, slicing as we just did, function call, and then an attribute lookup. So before I show you what this is, what do you think the double star means? So 1 star means multiply, but what does 2 stars mean?
Square.
Not square, exponentiation, right? So it's actually, the lights went off. So the double star means power or exponentiation. So like I can do 2 double star 3, so that's just 2 to the power of 3. And then we can actually chain these together if we want to, because integers are pretty much unlimited on Python, so we can make these as large as we want. So 2 double, it's just right associative, so it evaluates right to left instead of left to right. Okay? Because that's how it actually works in actual math. Okay, so we know what the plus means, which means for integers, pretty much all numbers, it means addition, subtraction. Actually, and for strings, the plus means concatenation. So what do you think the tilde is? Anyone heard of one's complement? Yeah, yeah. That's exactly what it is. Yeah. And these are, there's something called unary negation, so I encourage you to look up what that is, but you can apply a plus to a single operand instead of two. But that's just all that means. But it also means doing the binary operation, like a number plus another number. Actually, I want to show you something really, really cool. I think I've said that like 10 times today, but example 6, multiply. So I may have said earlier today that we can't multiply strings, but we can certainly concatenate them together. What if I wanted I wanted a string, but I wanted it 10 separate times concatenated together? So if I have our prototypical string, but I wanted 10 copies of that string concatenated together. So one thing I can do is I can make a for loop and then just do a whole bunch of concatenations. But does anyone know an easier way to do it?
Print
Yeah.
s times 10 or whatever.
Exactly. So print s times 10. So let's just run this. So Python 3 example 6. Yeah, so it prints the string 10 times. So it's actually really cool. You can overload operators in Python. You can overload the plus, minus, times, divide, and actually quite a few other ones, right? So string overrides the multiply operator that if we actually get an integer, we'll return this string strung together that many times, right? So it's actually really cool that you can overload operators like this. Cool. So what about if we had a list? So if we had a list is item 1, 10, 100, 10,000 maybe? What if I wanted this list? One thing we want is that we want these 3 elements in a list repeated many times in just one gigantic list. So how do you think we can do that?
Could you do list colon and then times whatever?
You actually don't. You can do colon, but you can actually just leave the colon out, the slicing out. So you can do print L times 10. So if we do that. So it just basically put all of these in a single list. So it's just basically it keeps adding to the list, the original list 10 times, right? So you can actually add lists together. So let's just say we have L2 is item 2, 10,000. So what if I wanted to add the contents of L2 into L? So how do you think we can do that? What would be the natural thing to do? L plus L2. So print L plus L2. So if we run that, it adds them to the list. So, yeah.
I was going to say, that doesn't actually make
it constructs a new list, yes.
but not permanently.
What do you mean not permanently?
So,
I guess it doesn't. You can't use that combined list.
I sure can. Yeah.
Yeah, you'd have to.
I see what you mean. Yeah, you would have to assign it if you want to use it. Yeah.
So you couldn't do like m equals print L plus L2?
Because you're not actually an assignment is not a value, right? So you're not really you can't send something that's not a value to something that prints a value. So let's just see what happens if we try that. So if we try that, so m is an invalid keyword argument. So that seems like a weird error, like keyword argument. Like it's something not to do with keywords and arguments. It just seems weird, right? So what happens here is a keyword argument is something that's really, really helpful. So it's that named parameter, named argument thing I mentioned earlier. So what you can do is instead of remembering the order of a particular method, the arguments of the method, you can assign what's called a named parameter. So what you can do is it's a variable that's constructed in the parameter list itself, and it's assigned a default value, but you can actually assign it another value via when you call the function saying this particular value equals some other value. We'll get into that, but that's why we actually get this keyword argument failure thing. Okay, so any questions on that? Okay. So we covered the first one, exponentiation, and then negation plus complement. So what do you think these 4 arguments are? Multiply, divide, something. Mod is definitely the last one. And since comments, as I told you, start with the pound symbol, so clearly we're not following Java's rules, which has the double backslash, meaning a comment. So it clearly must mean something else here. So what do you think it means?
It wouldn't mean long, would it?
What do you mean long?
Like, sorry, logarithm.
No, there's an actual function for that, so it's not logarithm here. It's like division, but something you may have seen many times. What's another type of division you've seen in Java? Like normal floating point division and integer division. So that's integer division. So you can actually, so the normal division automatically makes it a float. Oh, unless both arguments are integers, in which case, if it divides evenly, it is an integer. But there is an actual explicit operator which does integer division directly. And another really cool thing is modulo, which is the remainder operator, works on floating point numbers too. So if you do 3.5% 2, it returns you the remainder, which is 1.5. So it actually works on reals too, which is actually quite useful. So plus and minus, again, is addition and subtraction. So before, it was on one argument, which is the unary. So it was only one argument, but addition and subtraction are multiple arguments here. So what do you think a double angle bracket means? Shift left, shift right, yeah. So anyone not know what a shift left, shift right is? Yeah, so a shift left is basically in the bit representation, shifted in one position. So actually, let's just do that as an example. So example 7, shift. So let's just say we had a number 100, and we want to print S shifted shifted left one position. And then we want to print S shifted, actually the first one's shifted right, and then this one's shifted left. So what do you think is going to be printed? Shifted left one position in binary. So shifting left means take all the bits and shift them left one position in binary. So what is that effectively doing to the number? Shifting left. Shifting left would multiply it by 2, but shifting right, what would that do? Divide it by 2. So what should I see here? I'm shifting right by 1. I should see 50 because I'm dividing by 2, and this one is 200 because I'm multiplying by 2. So if we do Python example 7, 50 and 200 is what we see. Okay, so, but the cool thing is we don't have to do just one shift. We can do very, very large shifts. I actually don't know if this will work. Yeah, so if you shift right a whole bunch of times, it'll just be all zeros, yeah.
When would you use it? Like, I'm just trying to figure out why you would use it to shift right. What is the purpose?
Right, so what we're effectively doing here is dividing by 2 to the 100 and multiplying by 2 to the 100. So when you want to multiply by a power of 2, this is more efficient than just doing times 2 double star 100 or something.
That's what I was going to ask you next.
Yeah.
You're doing the same thing.
Yeah, that's the only use case basically for this, is to multiply by a large power of 2 to shift the bits. Because it's very efficient to shift bits instead of multiplying by a number, because it has to deduce that you could shift in that case. That's actually one of the optimizations that a compiled language does. When it sees, like in Java, when you say 2 times a particular number, it just does a shift. Like when it actually compiles to the bytes, the byte code itself, it does a shift instead. Okay, so probably one more slide. All right, one more thing. So shift left, shift right. So what do you think 1 ampersand is? Bitwise and. So take 2 arguments and then and look at each of the bits in order. If they're both 1, keep the result 1. If they're and otherwise, so one of them 0, keep it 0. Okay. So it's just useful for bit operations. We won't use that a whole bunch here. It's just for completeness. What do you think the caret is? It's almost that. It's exclusive OR. Yeah. So for the 2 arguments, if they're both different, keep the result 1. Otherwise, keep it 0. So if the bits we're looking at are 0 and 1 or 1 and 0, keep the result 1. And then otherwise, if they're both the same, then we keep the result 0. So exclusively 1 is 1 and 1 is 0. What do you think the single? Yeah, it's just a bitwise OR. So, and pretty much all of these now are obvious. So like less than, greater than, equals. So in Python we do have double equals, not equals, but we have these other ones too. So in is an operator where you check if a particular variable is in a collection. So we saw that with, if we look back. So if we look at the example for argv, we looked at for every single value in a particular list. But we can actually just do an if test if a particular value is in the list. So if, say, 100 in sys.argv. So what that does is it checks if the string is within this list. So it just looks through the list and then checks if the list contains that particular value you're looking for. Otherwise, it'll return true if it is. Otherwise, it returns false. Cool. Yeah.
How is that different than equals or equal?
So what am I going to do equals on here? And I'm just checking if a variable's equals actually works for equality. So unlike in Java where you have to call the dot equals method for 2 strings, here 2 equal signs really does mean the strings are equal in characters. Okay, so I don't think I have time for any more. So any questions before we break for today? Cool. I'll see you tomorrow.